various faculty development programs based on data science, decision science, and data analytics. Mr. Satyajit Azad is a consulting project with RITES Limited Gurgaon, National Institute of Hydrology NIH, SPML Gurgaon, and NPCL Noida. Over to you, sir.
Yeah, thank you, Prashant. So, good afternoon, everyone. I think you all have attended two sessions, so you might be, I think, tired. So whatever time I have been given, let me do what I can do best for you. So, I think just confirm, Prashant, if my screen is visible to you. Is it visible?
Yes, sir, it is visible.
Okay, thank you so much. So topic is the machine learning algorithms and explainable AI. Explainable AI is a new domain basically of artificial intelligence. Those who are into research might be knowing this, and also those who are new will get to know what is explainable AI. So, I mean, today I'll try to cover it, the basic of this machine learning algorithms. So, typically I'll cover this logistic regression. There is something called linear discriminant analysis. That is also a dimension reduction approach, and also to classify. The this also are similar with this algorithm is also similar with logistic regression basically, but it's different. They also reduce the dimensions. So we will see through the examples, and also we will take one small case of this Netflix and try to solve it using R. And also explainable AI, where I'll try to show you one case, and based on those data we will try to solve it using Python basically. So I'll try to combine both R and Python. And actually I have been told that few participants are of research domain, so they'll get to know so how you can apply this explainable AI in your domain as well. Okay. So, coming to this machine learning algorithm, basically. So, I think you might have seen these visuals
Excuse me, sir.
before.
Sir,
Yes.
when you will explain me us this machine learning and algorithm, you keep in
Mhm.
your mind that your student is don't have a engineering background. So you explain with the simple example, please. It's my
Okay.
request.
Actually, yeah, sure. Because my slides is basically it's a basic, and I'll try to cover it through the basic, what you are saying, so that everybody can understand. Okay. So there is slide included in it, so don't worry about that. Okay.
Thank
Is it
you.
fine?
That's
Okay. So coming to this machine learning algorithm, so typically, we divide it into supervised, unsupervised, and also there is something called reinforcement. So I'm not covering it here, but it's a supervised, unsupervised. But inside that supervised learning, there is something called classification and regression. Okay. So, I mean, classification, most of the time in business case, even actually, also I have handled a few, the government projects. So in that case, also I have seen most of the time they do some kind of a forecasting, but they also take help of this classification algorithms. Okay. So when it comes to classification algorithm, there are some simple classification algorithm like logistic regression, support vector machine, discriminant analysis. So here I'll try to cover LDA. So LDA is one of the classification algorithm, and also neural network. And also if you see the regression part, there are few regression algorithm which you might have aware of, like a simple, multiple. But logistic regression is a classification algorithm. Basically, it's not a regression. Machine learning algorithm. Okay, so decision tree also that can be used for classification and regression as well. But if you see the third, the last one, this neural network, basically it's a, the new on, and typically you can say the neural network can be applied for supervised, unsupervised, and also for clustering. Okay, so so as you said, cover it from the basics. So for that, I'm just use this slide. So traditionally, what normally we do, basically in C, C++, or Java, basically, we normally give input and algorithm to your computers, and they give you the output, simple output. If you can recall your C, C++, Java kind of, training program. In that case, you might have seen this inputting and giving some logic. Algorithm is nothing but it's a logic. You provide some logic to the input data, and machine will give you some output. That is a traditional programming basically. So hope I'm audible. Can you confirm? Okay. So now coming to this machine learning, machine learning approach where you give input and output at the same time to the machines. And through this input and output combinations, they read some pattern in the data. They find some pattern if there is some pattern in the data. And through this machine, if you feed this input and output to the machine, they give you some logic. Okay. So that is how your machine learning algorithm or machine learning works basically. So you can typically segregate from machine learning to traditional programming. This is how the basic you must know how machine learning works in this case. Okay. So now how machine learning projects basically you can handle it basically, and also in if you are working in corporate sector where you are dealing with this some machine learning projects and all. If you are trying to handle some enterprise AI ML projects, in that case, this is a typical approach you follow it. So first, basically, we gather some data. Okay, so actually, I am associated with some GIS that is called Geographical Information Systems firm. So in that case, we have a typical drawn data basically, and it is very difficult to process those drawn data basically. Okay. That require larger processor and all that. Okay, so for raw data, once you collect from the field or if it is secondary data, okay, so once you collect it, you try to pre-process it. So once your data is prepared, okay, you remove some noise, outliers and all, then you do some kind of a feature extraction. Okay, so where there comes PCA LDA, where you try to extract some feature out of the data which is given to you. Okay, then you apply some machine learning algorithms. Okay, why you apply machine learning algorithm? Because you try to read some pattern in the data which is already available but you don't know from the historical data. That is why you apply algorithms. That could be classification algorithm or that could be a regression algorithm. So regression basically works for predicting numerical value. If you are trying to predict or forecast some numerical value, then a regression will come into play. But when you're trying to do some kind of a classification, for example, I think yesterday, I think Professor Anun has given you one of the example of this loan data, right? So whether you want to give loan to XYZ person or not, giving a loan, or in your organization, few people are churning, you want to predict, if XYZ person will churn from my organization or not. That is a case of classification basically. So you build a model based on your historical data, and then you select a best model out of that. And there is something called ensembling that you get to know when you reach this decision tree, random forest, where do bagging and boosting. That is basically your model ensembling, and then you do some kind of predictive maintenance. So this is how your entire machine learning projects works basically. Okay. So now because I have given this example, I have taken this case just to let you know how logistic regression works. So in this case, just I'm trying to make some theory out of this logistic regression. So before you apply a logistic regression, just try to understand a business problem where you can apply logistic regression. Okay. So for example, a doctor wants to predict the likelihood of successful treatment of a new patient. Okay. Based on your historical data, if they have some historical data available with them, for example, if they have some blood pressure, hemoglobin level, even a blood sugar level, if they have if they have given any drug to that patient or not, if they have some historical data, right? And then they have a target variable called if they have some past cure status. So this is basically your class level basically. This is a target variable. So in typical classification problem, you have a different variable that is called a feature variable, and you have one at least this target variable. Okay, that is a class label. So in this class level, you want to give it two labels, that is a cure or not cure. Okay, so this is one business problem that most of the healthcare industry try to focus on, and what business benefit you get once you have this scenario and you have a data, right? So now applying this logistic regression or any classification algorithm on this data, historical data, what business benefit you can get out of this. So for example, given the health profile of a patient, okay, so and also the recent treatment they have given and the drugs, okay, so now doctor can predict the probability of a cure and identify the necessary changes to treatment and drug recommendations. So now you have a business problem. Now you have historical data, everything with you. You have applied ML, DL for that matter, and then you have taken some business benefit out of that. Okay, and then you can recommend a drug. So this is also one of the benefit of this MLDL in a real case scenario. Okay, so second case could be one of the loan. I mean, for example, most of the banking sector works in this way. So, for example, a bank loan officer wants to predict if a loan applicant will be a bank defaulter or not non-defaulter. So this is a two-class level problem. Okay, this is a classification, typical classification problem. We want to predict whether XYZ person will default or non-default. I mean, you have to predict it based on certain attributes. So I think some attributes typical bank sector capture is that they capture, for example, loan amount, monthly installment a person is providing, employment tenure, how many times applicant has delinquent annual incomes. These are some features basically. Okay, and based on that there is some class level called default and non-default. Okay, so this is how you can build a classification problem. That is why I'm showing you this example before trying to explain the logistic regression case. Okay, so now there comes because this is the some basic I have to build on. So let me try to define this supervised learning. So I think supervised learning is something we get to train on some kind of supervision basically. Okay, for example, typically in university, basically a professor teaches you, they supervise you, and then they give you a test. So this is how supervised learning works basically. Okay, so in supervised learning basically typical machine basically their task is to learn a function that maps an input and output based on an example, that is input output pair. So in supervised learning, I have shown you earlier one of the visuals where you provide input and output to the machine, and based on that they give you some kind of algorithm, they read some pattern in the data, and then they throw you some kind of equations. So machine learning model is nothing but it's kind of equation. It could be a mathematical equations. Okay, if it is some continuous data, if you have thrown to them, so they give you some kind of a mathematical equations to you. So that is what we call a mathematical model basically. Okay, so supervised learning, as name indicates, it has a presence of a supervisor. Okay, so you give some kind of a training to the machine, that is something called a supervision. Okay, basically supervised learning is when you teach or train the machine using the data that is a well labeled. So I'll let you explain what is labeled data and unlabeled data in coming slide. Okay, so typical supervised learning works under the supervision. You try to teach or train the machine based on your historical data, that is the labeled data. Okay, input and output should be there. In supervised learning, your data set must contain input and output pair. Okay, so now if you see these visuals, okay, so in this, if you see, there is a raw data basically. Okay, so now you're trying to supervise it, so there will be a combination of training data. Training data is nothing but it's an input, and you provide the desired output to the machine basically. So based on this input data and desired output, machine is giving you some algorithms. Okay, it's some formula, some mathematical equations that machine will throw to you, and based on that you process it, and then you for unseen data. Now training data is something that is historical data that is available with you. Unseen data is something that is called a test data. Okay, so based on this test data, you like to know whether a customer will churn or not. Okay, if there is a multi-class problem, then there will be third case also. Okay, so this is how supervised learning works. Okay, now This is one more visuals. This will make you more clear picture of this supervised learning basically. So in this labeled data, labeling means you are seeing this rate kind of a thing when if there is some similar kind of a figure, right? So this rate is we are marking it as apple, okay? And also this is strawberry. There is an image, there is some dimensions, there is some what you say during this image processing they keep some pixels out of that, so machine through these pixels get to know that this is strawberry. Now we are labeling it that this is a strawberry and this is apple. So labeling means data will have certain labels on that, okay? So in supervised learning, we have to deal with this labeled data. Okay. So if you have a labeled data, then only you can do some kind of a supervised, machine learning model building. If you don't have this labeled data, then you apply clustering basically. Okay. So for now, if you have a labeled data, then only you can apply this, supervised learning technique to build your machine learning models. If you want to classify it, whether this is apple or a strawberry, this is a classification problem. Okay. So typically machine learning takes help of labeled data to classify. Okay. And also if it is case of regression, then also you have labeled data with you to predict or to forecast. That is a numerical value. Okay. Now, so labeled and unlabeled data. Okay. So labeling means, for example, here, if you combine 1 and 2, for example, this is one data set. If you combine 1 and 2, it is giving you 1. And the label, this is a label basically. And we are seeing 1 or 0. Okay. This is a class label. Basically, this is a class label. Okay. This entire data up to this 1.4, 2.3, and 1 combination. This is a labeled one. But if you see below, there is a question mark. This is unlabeled. We don't know if you combine 4.3 and 9.2 input. Only this is the input, x1 and x2. But output, we are unaware of the output. This is called unseen data. So for training our ML and DL models, we provide a training data set where data is labeled. But when you are trying to test it, you give it this unlabeled data set so that they can predict you with help of this historical data. Okay, this is how labeling and unlabeling works. Okay, now, before building this logistic regression, now let me define it. What is the classification basically? Okay, so basically classification means it's a supervised learning approach. So classification techniques basically try to categorize or classify given data points into classes. This is very important. Okay. For example, if you take an example of a loan, defaulter and non-defaulter, this could be the two class label. Okay. Whether a person is going to default or not. This could be, divided into two class labels. So where comes the classification problem? Okay. For instance, for example, in e-commerce or even in digital marketing, most of the people deal with this spam and non-spam. For example, if you want to give if you want to roll out some digital campaign, if you have lots of email ID, okay, and there are some and you get some kind of you can say the spam. If you have some getting some spam email ID from XYZ digital marketing agency. So how you are going to know that this is spam and non-spam? In that case, also this logistic regression will work, and this is a classical a problem of this classification problem. This is a case of classification problem basically. Okay, predicting whether a monsoon will be next year or not, because you are trying to predict into two classes, whether there will be a monsoon, there will be a rain or not. This is a classical case of a classification problem basically. Okay, so classification could be fraudulent transactions. Most of the e-commerce company track this, and also the fintech companies, they deal with this, and so they apply this blockchain technology. Okay, so whether this rain and going to be rain or not, where there is a two-way classification basically, then you apply this logistic regression. Typically, if you have more than two classification, then you apply linear discriminant analysis. Okay, then I'll explain you how you can distinguish between this logistic regression and linear discriminant analysis. Okay, now I know how you are going to define this logistic regression. Logistic regression is basically a supervised learning technique to classify different. Uh, this is basically typically a classification problem. So logistic regression basically use this independent variable to predict the dependent variable. So in this case, dependent variable could be, if you take the example of this the banking scenario. In that case, if you want to give loan to a person or not, okay, giving loan to a person or not. So giving a loan could be one, and not giving a loan could be the zero, one and zero, the binary classification. So target variable, in typical logistic regression, we call it a target variable, whether you want to give a loan to xyz person or not. Okay, so it's a predictive technique, and also using this independent variable. With the help of this independent variable, you try to predict this dependent variable. Okay, just like linear regression, but there is a difference, okay, in with the linear regression and logistic regression. So in logistic regression, basically your target variable should be the categorical variable. So I think in yesterday lecture, one of the speaker was seeing the metrics. Okay, so he was referring to this categorical variable. Okay, so in logistic regression, your dependent variable must be categorical variable. If it is a categorical, you will apply logistic regression. If it is a continuous, then you will apply linear regression. Okay, because for linear regression, your target variable should be the continuous variable. Okay, so there is some thin difference between this logistic regression and that linear regression. Okay, linear regression is basically a regression problem, regression ML. Logistic regression is a classification, this problem, you can say. It's a classifier basically. Okay, so independent variable can be numerical or categorical variable, independent one, but the dependent variable will always be categorical. Okay, so this is a typical, you can define it how logistic regression basically works. Okay, so now there is some separation, you can say, the boundary, you can say. So I'll define it. There is something called a decision boundary in logistic regression, and also in linear discriminant analysis. Okay, so when the input, when the input can only be assigned to one of the two classes available, it is called a binary classification problem. Whether you want to give a loan to XYZ person or not, your customer is going to churn or not, whether you are getting spam or not spam. So that this is typical case of this binary classification problem basically. Okay, so one way to perform this classification is using the, obviously, a linear regression, but you can apply linear regression for the case of this logistic regression case. You can apply using this linear regression, but there will be a problem of threshold. I'll show you what is a threshold. Okay, so if I have given you a case of logistic regression case, if I have given you to predict the churn or not from XYZ company, if you want to apply linear regression, you can apply it, but there will be a problem, because how you are going to classify if if there is some value, let's say 0.5, in typically in logistic regression there is something called a threshold. If value is less than 0.5, it's industry norm basically, then you say it is a 0. If it is greater than 0.5, then we call it a 1. Okay, then we put it into class 1, and if it is less than 0.5, we put it into class 0. Okay, this is how basically logistic regression works. But if you are trying to solve it through this linear regression, then you have to apply this this threshold into that. Okay, but it is very difficult to do. That is why we take help of this logistic regression. Okay, so now you all know there is something called logistic function. Okay, that is called a sigmoid function basically. Okay, sigmoid function in maths basically, f of z equal to 1 divided by 1 plus e to the power minus z. Okay, this is a sigmoid function basically, and sigmoid function basically oscillates between 0 and 1. The value cannot go beyond 1. The threshold of this sigmoid functions is that minimum value will be 0 and maximum will be 1. Okay, so that is why for binary classification problem, this sigmoid functions works, and logistic regression use these sigmoid functions to classify the data sets based on the historical data, whether you want to give XYZ person loan or not. So that could classify into 1, And if you don't want to give loan, then that could classify into 0. So this sigmoid functions works well in logistic regression to come up with this class level. They predict using this sigmoid functions to come up with this class level. Okay, and sigmoid functions is typically X curve. If you see this, this is typical S curve basically. Okay, now so there is something called decision boundary in logistic regression. Okay, so decision boundary is nothing but you're trying to create some kind of wall between the two classes. This is something you can refer it as a decision boundary, because ultimately you have to take decisions based on the historical data, whether you want to give loan to XYZ person or not, how you are going to do, there will be some kind of a threshold. There will be some boundary where you will stop and you will say, no, you are not going to give loan to this person. And there should be some logic. So that is why you take help of this decision boundary. Decision boundary in logistic regression is very important. Okay, so decision boundary is nothing but it's a line basically. And also, if people who are aware in this, there is something called support vector machine. This is also a classifier basically. Also, you can do regression, but most of the time people use it for a classification problem. So there comes a concept of this hyperplane. Okay, hyperplane is nothing but this is something called a boundary that separate two classes. Okay, so logistic regression can use linear equation, with independent variable to predict a target. Okay, so you must have 3, 4, 5, 6, depending on your business problem. There should be some independent variable to predict the class basically. Okay, so predicted value can be anywhere between the negative infinity to positive infinity. Okay, to overcome this problem, we normally use this function that is called sigmoid function, so that we can skew the data so that the value cannot go beyond 1 and cannot go beyond 0. Okay, so this is called a sigmoid function. So sigmoid functions are very important to create a separate decision boundary to predict the class using this logistic regression. So this is how you can explain this decision boundary. Okay, so this visual is also important, but for example, in this case, if you see this one, if you take this example of one of your company you are working in, and your management trying to predict, whether my employee is going to churn. Okay, so 0 could be the churn, 1 is not churn. Okay, and this is a decision boundary. Based on your some features, you have calculated this one. There are two class levels. Basically, these are the class level. Okay, 0 and 1. 0 is churn and 1 is not churn. Okay, so there comes a decision boundary, but for this decision boundary is very small. Sometimes you get confused, and also your ML algorithm get confused and they predict you the wrong value. That is why there comes there is a concept of confusion matrix. Okay, so in every classification problem you come up with something called a confusion matrix to check the accuracy and performance of your model. Okay, so now so logistic regression versus this linear regression. Okay, so in logistic regression and linear regression, so in linear regression or multiple linear regression, basically value of y, the value of predicted value, or you can say the forecasted value, can go beyond 1. Okay, so and also it can go negative. It can take a negative value, the predicted one, the forecasted one. That is why it's a straight line going beyond 1 and also going beyond a negative value. Okay, but in logistic regression, due to the sigmoid functions, the value cannot go beyond 1 and cannot go beyond 0. Okay, so this is a simple you can say the separation, or you can say the distinguish, how you can distinguish. This is how you can distinguish between this linear and logistic regressions. Okay, in logistic regression they use this sigmoid functions basically, and also in this linear regression they use something called a cost function, that is called a learning rate basically. Okay, but for now just remember that the value of y, or the class level, or you can say it cannot go beyond 1 value and cannot go beyond the 0 value. It will oscillate between 0 and 1, and there is something called a threshold value. You can keep it as a 0.5 as a threshold value. If y predicted to be more than 0.5, that is a boundary. We can call it as a 1. We can put it in a class 1, and if the value is less than 0.5, you can put it into 0 class. Okay, and you can call it, for a business problem, it is a churn that will be 0, not churn 1, something like that. Okay, now, so typical, the logistic regression, I have shown you this typical, this data set. So how, data set of this logistic regression looks like. Okay, for example, for a XYZ company, if you are trying to churn, okay, this is historical data basically. This is of 5 instances. Okay, so in these 5 instances, independent variable, how many independent variables are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all are independent variable, but in classification problem, we call it a features. We call it a feature, okay, or variables. Also, we call it an independent and dependent variable, but most of the time we call it in a regression problem. But in classification problem, we call it a features. And this is called a target variable. We don't call it a dependent variable, we call it a target variable. Okay. So based on this feature variable, you are trying to predict, or this is basically input combination, this is output combination. So for training your data, you require this input and output combination so that you can feed it into machine learning models. They can read some patterns out of that. They can build some model out of that. And if you have some unseen data, let's say if you have some unseen data here, this is unseen. Fourth record is unseen basically. And based on this feature, now we have this, okay. Now you have a new, let's say, employee. This is a new employee. His tenure is 7 years, age is 35, address is, let's say, 14.0, income is 80 point, ED employee. These all are the, unseen one. Now you have given the model to predict whether he will churn or not. This is the case, typical case of logistic regression. Okay. So now, when you can use this logistic regression, okay. So typical, this, the way of using this logistic regression is that, when your target data is binary, if you are dealing with this binary problem, if your target variable is binary, and most of the case in real life also we deal with a binary situation, and also in business problem, most of the time we deal with this binary case. Whether I want to purchase a laptop or not, whether I want to go to a movie theater or not, whether I will be given a loan or not, whether my salary will hike or not. These are the some cases we deal normally. Okay, so this classification problem will come everywhere. Okay, so if your target variable is binary, then you can apply logistic regression. If you need a probabilistic result, okay, in that case also you will apply this logistic regression. When you need a linear decision boundary, I have shown you that there was some decision boundary. So logistic regression apply linear decision boundary. There is something called decision tree. They use non-linear decision boundary to predict the new outcome. Okay, logistic regression use this linear decision boundary. There is a small difference in that. If you need to understand the impact of a feature, for example, if you like to understand the impact of these features on churn, in that case also you will apply this logistic regression. Okay, these are the some area where you can apply this logistic regression. Okay, so now these visuals will give you more clarity how regression and classification, how you can visualize this regression and classification. Okay, for example, what will be the house prices be like in my town next year? Okay, this is a classical case of a regression. But when we just paraphrase it, and when you say, will houses be affordable in my next, in my town next year? So this is a binary problem. This is a binary, affordable and maybe non-affordable or expensive. Okay. So this is a classical case of, this regression and classification. Okay. Now, so regression and classification, there is some difference. One of the important, the classification, I can say one of the biggest, the classifier, or you can say the important aspect of this logistic regression is that your target variable must be categorical. For regression, it should be continuous. The rest of the things are similar. Okay, so but you have to give emphasis to this one for classification problem for logistic regression. Here your target variable, your response variable, your dependent variable must be categorical. Okay, so in regression it's a reverse, it should be continuous. Okay? So now let me give you, I mean, let me show you one of the, I have taken one small exercise and R so that we can save some time. So now this is one of the case. Just read this case basically. So for example, let's say you are developing your online clothing store. Okay. Okay. And some of your customers are already paying full price, but some don't. And you want to create a promotional campaign, and you want to offer discounts codes to some customers, not all, in hope that they might increase your sales. Okay, but you don't want to send discounts to customers which are likely to pay full price. How should you pick up the customers that will receive discounts? This is a case, I mean the classification case, and I'll show you the data set here. Okay. So in this data set, if you see, there are, this customer ID, amount spent. This is basically a feature, or you can say for now, independent variable. But sending discount, this sending discount is a target variable. This is output, you can say, okay, or response variable, you can say. So this is historical data available with me. Now, looking at this data set, because if you see this data set, this response variable, 0 and 1 combination, this is a categorical basically. So by looking at this data set, at least I have a clue that I'll apply some classification algorithm. This could be your logistic regression, support vector machine, decision tree, random forest, neural network, LDA, there are many more. Okay. So depending on your requirement or research requirement, you can apply different classification problem. But here you can see the R response variable is categorical. So obviously one of the algorithm which I can apply is logistic regression here, okay, to come up with the class label. Okay, now let me run my if you have any question you can ask in between. Okay, so okay, so now amount spent, this one, if you run it, okay, so amount spent, if you see, is 50, 10, 25, 95, 70, 100, 200 and 0. This was the amount spent, and the sending discount was 0, 1, 1. There was one more field or what? 1 minute. Check. Okay, so this okay, so we are removing this customer ID. Okay, here we are not including this customer ID. We are only taking this amount spent is one independent variable. There is only one feature available with me now. What is that feature? Amount spent. And based on that, I have one response variable, that is a sending discount. Okay, there is only two input and output, only combination of input and output. Okay, so amount spent is a feature variable and sending discount is a target variable basically. Now I'll build some machine learning algorithm, that is a logistic regression. Okay, how we can apply. So logistic regression basically, typically this is user defined. Okay, logistic, we can use it for example, logistics, lm, and less than minus. glm is a basically a generalized linear models. This is one of the functions in R. For modeling this logistic regression, we call it a generalized linear model, GLM. Okay, this is a function basically. Okay, and then we say send discount, and this is a tilde sign. This is basically this will show you a relationship. Okay, now this is a feature variable. This I have picked up from this column. Okay, sorry, this. Okay, this is send discount is a response variable. Typically we write it first, send discount. This is a response variable, and trying to establish some relationship. Tilde sign is showing some relationship. What kind of a relationship having with this amount spent and sending discount. Okay, so amount spent is your feature, and sending discount is your target variable. Okay? So once you run it, and also there is some command called summary command. Okay, and we put this one logistic lm. So once you give run this command, this will give you some summary stat. Okay, so if you see, this is a typical formula we applied here, and also they have given us some kind of a coefficient, some coefficients. Okay, so this is basically an intercept, but valuable for us was this amount spent, and corresponding to amount spent we got some this estimated coefficient. And this estimated coefficients, there is some error attached with it, how much error it is throwing with this coefficient. So this is error, standard error basically. So but we are not interested in this, we are only interested in this coefficient. I'll tell you why. Okay, and also this is significant, means it means significant means it has some impact on what, it has some impact on this sending discount. Amount spent had some impact on sending discount, because this coefficient is significant. A star mark shows you significant, the value should be less than 0.05. Okay, now once you have this coefficient, okay, now you want to predict it. Okay, so now let me come to my PPT. So okay, so I have applied the same formula here. Okay, so now let me explain. One star, basically when you see the star, basically this shows you a significant value, because there is some impact of this independent variable on dependent variable. This is how you can interpret it. The value should be less than 0.05. Okay, so now if I have a new customer, let's say, okay, and he is spending $10. Okay, $10, let's say. So should I send should I send a discount to that guy or not? If he is spending, let's say, a new customer who is spending $10 here. Okay, so the typical formula would be, how we can come up with this formula from this logistic regression, because when you are building a model, we are coming up with this some kind of a mathematical equation. So from this equation, if you see 0.082 is intercept. If you see this one, I have taken from this value from this. Okay, 0.82 plus and minus, because this is a minus sign. Okay, this is a minus basically, and 0.062. This is, there should be one more zero, so don't worry. Minus 0.0062. Okay, and a star, because this is the coefficient of amount spent, and their coefficient at this, that is why we will multiply it, equals to send discount. So this is mathematical, or you can say mathematical model of logistic regression we have derived from the historical data, whatever we have in the training data. Now the question, if I ask you, okay, if there is one customer whose spending is $10, should I send discount to that person or not? So I'll put this only 10 here, amount spent here, multiply it, and the value will comes out to be 0.758, which is more than 0. This is the threshold value. Okay, now from this formula, this mathematical model, now I can say and predict that yes, I will send discount to this person whose spending is $10. Okay, this is how we are going to predict it, and we are going to classify this customer based on your new data, unseen data. We are classifying it, and we are saying it, put it into class 1 and send the discount to that person. So this is how your logistic regression works. Okay, so now anyone has any question so far? Any question? Okay, no question. So okay, so now second topic is your linear discriminant analysis. I think in previous session also, I think one of professor has discussed this linear discriminant analysis. Okay, this is also a classification problem, but there is something attached with it. It is, they also reduce the dimensions. Okay. Okay, this is important one. They classify it, but reducing the dimensions. Okay, LDA. So now there is something called a positive discrimination. Discrimination is obviously a negative word, but there is something called a positive discrimination. So linear discriminant analysis use this discriminatory approach to classify whether you want to give a loan to XYG or not. They use this discriminatory approach to classify it. I'll explain it. What is this positive discrimination approach basically? Okay. So sometimes this discrimination is good. Okay, discrimination is negative as I already said, but positive discrimination. Okay, it's a good sometime. Okay, so obviously discrimination is bad when differentiation is achieved using in a negative way. Okay, otherwise you can do some good things can be done with the help of this ability to discriminate. So linear discriminant analysis has the ability to discriminate, and they can easily classify based on the historical data. So they have this discriminatory power. Okay. So discriminant analysis is obviously a loose derivation from the word discrimination. It's a concept widely used to classify labels of an outcome. Labels on outcome, this could be, if you want to give a loan to a person or not giving a loan, and their label could be no and yes. There are the two labels. That labels means that yes or no. Okay. In other words, it is useful in determining whether a set of variables are effective in predicting category membership. Okay, whether a person having age of 35 years, having experience of 10, and he has credit card or not, something like that. If they have some, this data available with them, how I can predict that category, where he will belongs to, what will be their membership basically. So LDA has a more powerful, technique to discriminate it. That is why it's better, much better than this logistic regression. Okay. Now, there is something called, dimensionality reduction. Okay. So in dimensionality reduction, basically, you're trying to reduce the dimension. So for now, if, for example, giving a loan, if XYG company uses let's say 10 features to come up with giving a loan to XYZ person or not. Okay, so that 10 features could be the 10 dimensions. For now, just understand 10 features is 10 dimensions. Sales and revenue, for example, sales and revenue. Sales is, let's say, is an independent variable, and revenue is a dependent variable. In that case, it is a two-dimension problem. You can easily plot using X and Y coordinate. But let's say, imagine if you are dealing with 10 such features, and now you have to plot the data into 10 dimensions. It's a tedious task because we hardly can understand 3 dimensions data. We can easily read 2 dimensions data, but more than that, it's very difficult to interpret. Okay, human's brain cannot take much of this cognitive load. So that is why in this data science, this dimensionality reductions comes into play. So dimension reductions has a two way to deal with. One, if you have a data set is supervised, in that case you will apply linear discriminant analysis. If your data set is unsupervised, okay, in that case you will use principal component analysis. That is called PCA. So fewer input dimensions often mean correspondingly fewer parameters of a simpler structure in the machine learning models, referred to as a degree of freedom. If let's say if a data set has 10 features, then you will say they have 10 minus 1, 9 degree of freedom. Okay, so a model with too many degree of freedom is likely to overfit the training data set and therefore may not perform well on a new data. So, and also in data science, there is a problem of underfitting and overfitting. Okay, if you have a more data set, there could be a problem of overfitting. If you have a new unseen data, they can easily predict it, but the performance of model will be very poor. So to deal with this overfitting and underfitting, there comes a concept of this linear discriminant analysis. Okay, so there are large number of techniques to reduce these dimensions. There could be forward, backward, feature selection, or there are many. But here we will try to understand this linear discriminant analysis. Okay, now, so linear discriminant is basically a powerful linear transformation. Okay, so people who are aware of this linear algebra, they apply this linear algebra. There is a matrix, multiplication, division, and all. So linear discriminant analysis, basically they use this linear transformation to come up with this dimension reduction. Okay, so there is also a black box technique. So now let me define it a black box. So when we are dealing with this machine learning, problem or machine learning algorithm, most of the time machine learning, this advanced machine learning algorithm has a black box. We don't know how they are coming up with this output. We have given input and output. We don't know how they are predicting it. What is going inside this black box? What they are using it? For example, artificial neural network, random forest. These are the the black box. They use black box methods, or we can say, to come up with this the output, or they predict it. Okay, you don't know how they are calculating it. So to deal with this black box, I'll use this explainable AI to make you understand how they are coming up with this, the mathematical calculation behind this mathematical, this machine learning algorithms. Okay, it's very complex. Okay, to understand this black box, we are coming up with this concept called explainable AI. Okay, so LDA is basically a supervised dimension reduction technique. The goal is to, the project a data set onto lower dimensions with a good class separability in order to avoid overfitting. So let me show you one of the visuals, then you will understand what I'm trying to say. The class separability, okay, how they are going to separate the class. Okay, so linear discriminant is a linear machine learning algorithm used for multi-class classification. In logistic regression, most of the time we deal with this binary classification. But in LDA, if you have more than 2 classes, we can easily apply LDA. Okay, LDA used for compressing the supervised data. What they normally do, LDA algorithm basically compress the data so that you do not lose much of the information out of that. Okay, so when we have a large data set, obviously having more features or more class, we can say our data is normally distributed, features are not correlated with each other, then we can use LDA. Okay, if your data set is highly correlated, for example, if 2 features are highly correlated and there are multiple features which have a more affinity, or you can say more correlation, or you can say multi-collinearity exists in the data, in that case you cannot apply LDA. It will give you some vague result out of that. So linear discriminant analysis, what normally they do is they seek to best separate or discriminate. This is the important word. What normally they do is they discriminate the samples in the training data set by their value, class value. Okay, specifically the model seeks to find a linear combination of input variable. Obviously LDA will give you some coefficients. So in that case, they try to compress the data by not reducing the original informations. Okay, so between the class, okay, so the model seeks to find linear combinations of input variable that achieves the maximum separation for the samples between the class. That is basically based on means. I'll show you, there is more visuals, then you will understand what I'm trying to say in LDA. Okay, so now if there is a two class means, let's say this red is churn and this blue, this one is not churn, for example. Okay, there's a 2 class basically. Okay, so between the class, there should be more variance between the class, but within the class there should be less variance. There should be less variability within the class, but more variability between the class. This is how LDA works, and they separate it. That is why they use this discriminatory approach to come up with this decision boundary to separate the class. Okay, so this is how LDA works basically. Okay, so LDA is, if there is a 2 class, blue and red, there is a 2 class basically. So based on this class, if let's say this is a plane basically, this is X and Y plane, and this is a 1 class, this is, let's say, churn, and this is a not churn basically rate. If you rotate the axis, and based on this we have plotted the histogram. Okay, we have plotted the histogram, and then LDA normally rotate the axis. In this visual you can see they have rotated the axis so that they can bring the clear distinctions between the class. That is why they rotate the axis in a such way that they create some kind of a distinctions, so that there should be a class separability in LDA. they rotate it. Okay, so typically they work in this way. Okay, now, so this is similar. Okay, one of the example, this will make you more clear example. Okay, so in this example, just take and consider a simple problem in which you want to decide whether a drug should be given to patient or not. Our features will be gene expressions, and we will have a two class label. Okay, for patients which the drug work or not. So for example, there is a two features, gene X and gene Y. Based on that, we are saying drug should be given or not. Let's say red is drug given, and this blue one is not given. Okay, based on this is a class, basically two class, and how we have plotted this class based on these two features, gene X and gene Y. Okay, now based on this scatter plot, okay, we are interested in, I mean, for PCA, basically, I'm not going to explain this PCA, but in LDA, we are interested in maximizing the separability between the two classes. If you have a two known classes, our aim is just to create a distinction, separation. We're trying to create more separation. How we are going to create these separations? Okay, this is one of our tasks. Okay, so now what we are doing is we are trying to, if this is a two-dimensional data, we are trying to coming up with this one-dimensional data, but one dimension doesn't mean, I mean, projecting entire data set into x-axis. No, we are coming up with one LDA. LDA will create a new axis. Okay, so in 1D doesn't mean we are trying to compress entire data in a single x-axis. It's a bad way because you will lose much of the information. But LDA normally creates a new axis. Okay, so LDA does is that they create a new axis basically to maximize the separation between the two categories. Okay, so if how they are going to draw this line, this is line of best fit basically, and they try to measure this distance basically. Okay, how they are far from this line of best fit. Okay, and then they will rotate this axis. Okay, so now they are coming up with this, once they have measured this distance based on this line of best fit, they have measured the distance, and then they rotate this axis, so that by creating a new axis, they are not projecting entire data points into x-axis. They are LDA creating a new axis so that every data points can be captured in this line. Okay, in this way you can see. So our entire class is scattered, or you can compress it into this new LDA. Okay, so that we do not lose much of the information. And LDA, what they did is they reduce the dimensions. Okay, now it is only one dimensions. We can easily interpret. Okay, what is this data point? Okay, so now the new axis, how this new axis is created basically. New axis is basically, this is a mean. Okay, this is a class mean. Okay, so the new axis should maximize the distance between the two means. So LDA has given us a new axis. So now new axis will create the more separation between this class mean. The mean of this, let's say 0 and 1. The mean of 1 is mu plus, and mean of this 0 is mu minus. Okay, and LDA will maximize the distance. This distance should be maximized. Okay, and also what LDA does is, this is a variance basically. They try to reduce the variance, minimize the variance. Okay, and maximize the mean, maximizing the mean and minimizing the variance. Okay, this is how LDA works. Okay. And there is something called optimizations. So this is a simple formula. Typical LDA, when you apply LDA, I'll show you through one of the data set how you can apply LDA. LDA use this optimization technique to come up with this distance, how they are going to reduce the distance by reducing this class mean and minimizing the variance and maximizing the mean between the class, within the class. Okay, this is how optimizations works, and this is a typical formula of optimization. If you have more than two classes, you can increase, add, and subtract. Okay, this is how it works. This is a typical graphical representation of LDA basically. So how we are going to graphically represent this LDA. Okay, for example, if you have a two class, Okay, 1 minute. Where is the cursor? Okay, this one, I mean this color, whatever color is this, let's say it's a green one is 1 and black one is 0. This is a two class label and we have plotted based on this variable 1 and 2. Let's say we have a two variable and this is a char and this is a not char. How we are going to perform LDA graphical? Okay, so now we have drawn a new axis. Just see, this is a new axis and we have captured it in this new axis. If you see this axis is coming from how we are going to capture it. Okay, we have captured in this whatever there. Okay, this is the mean of this 0 and mean of x1, and this is a standard deviation. You can say it is, this is a variance and variance. Now now this line, now we are going to rotate this line. This new line is now this line now. Okay, now you are going to project it like this, variable parallel to variable 2, and now we are capturing it, everything in this data point. We are trying to compress it in this line. Okay, and now you can see there is some difference. The variance, the variance is reduced. In this case, variance is reduced. Now we are trying to put this line like this. This line is now here in this case, and then we will capture it like this. So LDA normally coming up with this new projections every time. This is iteration methods. Every time they iterate it and they give you some optimized value so that you get some, you maximize the separation between the class means and minimize the variation within the class levels. This is the all game of this LDA, so that they come up with this class levels. If you see, if you have some new or unseen data, how you are going to put this label to that class. Okay, so this is how LDA works. And this is a simple one, defaulting and non-defaulting for understanding purpose. And this is a class, basically separation parallel to this W. This is a W is basically a hyperplane perpendicular to this one. This give you class separation. So this is how it works. And based on those two features, we have separated those two classes, defaulting and non-defaulting, by separating it. So this is how LDA works. Okay. So let me do some R programming. I have also taken one example for this LDA. So this case, just see this case. I mean, in this OTT platform, this Netflix produces very popular and high quality content. Okay, for digital platform across the world. So subscriptions are measured in terms of money spent. For example, if you are consultant to this Netflix, and I have given you this data set where I have given you two data points, let's say money spent on subscriptions and watching time. And also I have given you the result of this Netflix subscription. Okay. So how you are going to analyze it? Okay. So there is data set here. So now it's your job now as a consultant to Netflix. You get a task to set up this criteria for automatic subscription control. Okay. Now you're as a consultant to this Netflix. I mean, you have given this task to automate this subscription control. Then how you are going to do that. So for example, you have this historical data up to this. Okay. Up to this one, 3.27, 3.52. This is a labeled one because we know this is two input and this is output. Or we can say this is the feature variable. This is a response. Subscription is a response variable or target variable basically. Okay. And now there's a class label. There are two class labels. One is subscribed and second class label is not subscribed. Okay. So now how you are going to solve it? Now you have to solve it through linear discriminant analysis. You can also apply logistic regression, but now it's a case of this linear discriminant analysis because we are trying to separate the class so that prediction could be much better. Okay. Now coming to this R. Okay. So for this Netflix case, there are some library. I think all libraries are not required, but you have to run this library. You have to install it. For example, this psychology library and this mass library is must. But let me run it, all these libraries, okay, to run this LDA. Okay, now Netflix LDA and this one. Okay, let me explain you what is this. This is user defined. Netflix LDA, you can put it anything XYZ also. Less than minus read.csv means we are reading the file. It's in my C drive. Name of and also name of the folder is neural network, and inside that folder my CSV is saved. Netflix LDA data.csv format. Okay, got it? So in R, basically, we are trying to read it from from our desktop, obviously, from our folder. It's saved in C folder. I mean, in the C drive, in folder neural network, and the file name is Netflix LDA data.csv. This is how you read it. Okay, this is simple. Okay, now, so and what is in Netflix? Let's say Netflix. Oh, I'm correcting Netflix LD. Okay, with this name. Now, this is the same data which I have shown you in the PPT. Okay, MASS, mass, and WT. Okay, watching time and the subscription. I mean, the time spent, money spent on subscription. These are the two feature, basically independent variable we say, and this subscription is a target variable. Okay. So this data set was saved in that CSV format. Now we will apply this linear discriminant analysis. Okay, just hold on your thought. Now, this model is also user defined. You can give it any name. Let's say model 1, 2, 3, and less than minus. Also, you can put a equal sign also. And this LDA is a linear discriminant analysis. LDA is a function basically. And this subscription is basically a target variable, and this relationship with this target variable is being shown using this MSS plus WT. Okay, this is independent variable or feature variable. You can see from where I have picked up. Okay, and this subscription is your target variable, if you can see. Okay, and the data, Netflix data, this is saved here, because entire CSV is this entire CSV is saved into this Netflix LDA. That is why I have used this Netflix LDA here, and I am seeing my data is stored where, in Netflix LDA. Okay, there is something called prior probability. Looking at this data set, how many times one appeared is out of 7 records, 4 times 1 and 3 times 0. Okay, I mean three times subscribed, 1 and 2. One is subscribed or not subscribed. Okay, subscribed is 4 times, that is by 4 by 7 out of 7. Not subscribed is 3 times, that is by 3 by 7. You have to put it in LDA, the probability. Okay, so LDA is a function, subscription is a response variable, MSWT is a feature, data set is saved in this, and we have put up this prior probability. Okay, now I'll run it. Okay, okay, actually I have run it already. So now I will put this model, this command, and just run it. You see this, this will give you prior probability, which is nothing but 4 by 7 and 3 by 7. Okay, and also they they give you this group means. Okay, group mean of WSS and WT we have seen in this optimization formula. They give you this group mean, and also they are giving us this coefficient. This is called linear discriminant coefficient. This is very important. This is coefficient basically, and because there was 2 feature, that is why they have reduced from 2 feature to 1. This is case of dimension reduction. How many features were there? 2 feature was there, but I am getting 1 LDA score. Why? Because they have reduced 2 to 1. By reducing the dimensions, they have given us some coefficients, and now I am going to predict it. Okay. For example, there is a new customer. Okay, now we are going to predict it. For predicting a new customer, for example, this all, let me run it. data points available with me now. For new customers, I have 2.81. I mean the watching time, you can say, or money spent on this subscription, and 5.46 is your watching time. I think it's in hours. If this is the customers, I have data point available. Whether he will subscribe to this Netflix subscription or not, this is the case. So basically, this is a few commands, okay, to make it a this I mean this data frame, and we will try to predict it. Okay, for new data, df.new, okay, because we are saving it a new data from new.data to df.new, okay, and putting it a class level. You are saying which class I have to put it if new customers have these features. From this, they are saying put it into class level 2. Okay. So now a person is not going to subscribe it from this data. This is what they are saying. Okay. So they will not going to subscribe it. Okay. So now, so this is how your LDA works basically. This is what I have used it here. This is the same output from the R. So LDA is saying that if a customer have a 2.81 MSS and 5.46 WT, then he is not going to subscribe it because they are predicting our class to be 2. Okay. So using this linear discriminatory approach, by reducing the dimensions, they are also coming up with this class level. This is a classification problem. Okay. LDA. Okay. So, and also you can use LDA. I mean, there are different way to use it, and when you can use it, I mean, it's a simple one. And there is some difference between this LDA and logistic regression. So it's very important because in linear discriminant, I mean, just see this one. It has an advantage over logistic regression because it has it can be used in multi-class problem. Linear discriminant can be applied for multi-class problem. Okay. That is why this is very important, and also stable because classes are highly separable in this linear discriminant analysis. Okay, that is why most of the researchers prefer this linear discriminant analysis over logistic regression, because logistic regression is a basic ML technique basically. Okay, they require less training time for their data set. Okay, it's such a basic ML algorithm basically. Okay, now this is very important topic, keeping this research in mind. Okay. This is a new area, explainable AI, and also I have worked in one of the project in this explainable AI. So explainable AI is a new and emerging field and very important field. Okay, why I'll tell you. So explainable AI is basically, I mean, collectively you can say refers to the technique or methods which help explain a given AI model. For example, I have built this linear discriminant analysis model and logistic regression. I have given you this equation and everything, but I'm unable to explain because this was the small data set. We can, using this gut feeling, you can explain that how model is behaving. But if you have, more feature and everything, if you have lakhs of record, and if you have 200 such features, in that case, you will not be able to explain the model. Okay, that is why there comes a concept of this explainable AI. Okay, so this is a new found branch of AI and has enormous potential basically, and also more sophisticated techniques are coming each year. Okay, people are researching, and every year you'll see a different research paper also, and people who are in research can easily relate with this. You will find lots of paper and in Scopus journals and all. Okay, and also Web of Science and all. If you have access to it, you will find different explainable AI research papers. And some of the the famous this XAI, we call it XAI, that is explainable AI. There are different methods, you can say, or also you can say the framework. One is SAP, that is called Shapley Additive Explanations. Another one is Deep SAP. You can Google it, and also you can find some papers. Deep Lift, CX Explain, and Line. I will be explaining this line, this model, these methods, using this one of the data set to make you understand how you can leverage this explainable AI to explain your different black box methods. Okay, black box methods is basically advanced machine learning models. That is called a black box, basically. Okay. So, what is basically motivation behind this AI? Explainable AI. So, it's a vast field of this AI, and with newer and more complex models coming each year, AI models have started to surpass human intellect at a pace that has, no one could have predicted. So obviously, AI has more capability. They have a more with coming years, they are gaining more maturity. So they can easily predict our humans have some limited limitations. You cannot see all the patterns in the data. If it is huge data, it's very difficult. So that is why AI models or the machine learning, deep learning models are getting matured. Getting matured every time. And also a new research are coming up. So, but as you get more accurate and precise results, it's becoming harder to explain the reasoning behind the complex mathematical decisions. So, for example, if I give you a neural network model, a random forest model, you can apply using this data set using Python and R. You can come up with this different nice model. But if I tell you to explain why these features is behaving like this, so you will stuck in that because you don't know how your this black box you don't know how input and output is getting converted inside that black box. Okay. So that is why it's becoming harder to explain the reasoning behind the complex mathematical decisions. That is why explainable AI comes in, and mathematical abstractions also doesn't help users to maintain. Obviously, with GDPR regulations, most of the this machine learning, or you can say the data analyst or enterprise, you can say the dealing with this AI and ML, they are saying government to come up with this explaining the AI models, how they are coming up with these certain decisions. If you have to deal with this healthcare data or fintech data, in that case a slight wrong can deviate you to lead take wrong decisions. That is why it's very difficult, and also it's very important that black box methods must be explained to users so that people have a more trust in AI models. Okay. For example, say for example, if you have built a deep learning models using let's say artificial neural network, and for example it takes an image and predicts with 70% accuracy that patient has a lung disease. Okay. For example, in the COVID, you can take a COVID example. Okay. Through the model might have given the correct diagnosis. It may possible that using this the data set whatever they have available with them, this model has given them the right predictions or correct model. A doctor can't rely the advice and also give sorry the a doctor can't really advise a patient's through confidence, as he doesn't know the reasoning behind the models we are applying, because doctors don't know how the features are behaving. Because model has given you some mathematical equation, it doesn't mean you all know how you are unable to interpret it. Basically the black box, you don't know how input and output combining with and giving us the result. Okay. Because in healthcare it's very important to understand the impact of every features, how you are going to interpret the models. Okay. So now there is something called this there is intersection in this explainable AI. There is something called understandable AI. You can understand it. Transparent AI. For example, linear regression, you can easily understand how features are behaving. This will come under understandable AI, and also it is transparent. For example, decision tree. You can understand it how different nodes are splitting. How you can say there are different you can say different parameters to split the node basically. So that you can easily understand. That is a transparent and also understandable. But uh, neural networks, if it is a networks, you don't know. So in that case, it's a that will come under XAI, explainable AI. Okay. So now this is a typical this visual or this explainable AI. Normally when you build a MLDL models, we have a data and everything. Then we have black box. For example, artificial neural network, we have a different layers, hidden layers. that we can count it as a black box. We don't know how those nodes are converting input into output. We don't know. We give some data to the this software, and they calculate everything for you. Okay, you don't know how they are coming up with this logic. And then we build some AI applications. This is a traditional, what we are following right now when we are building this MLDL. Okay, and then we take a decisions. But still, there is some confusions, and there are some questions that to be answered. What are these questions? For example, why is the forecast like that? Once you have result with you, you will unable to understand why the forecast is like that. Why are the predicted sales low? We don't know. What features leading to the lower sales value? We don't know. Why is the this cohort not converting? Why are these customers similar? These are the some the confusions still will be there even if you build machine learning models, okay, in a traditional way. But there comes a concept of this explainable AI to clear this confusion. Okay. Okay. So now in explainable AI, you have a data, and also after the black box, there is something called explainable AI. You can say the framework that we can apply. Okay, so for example, I'll show you using the Lime how you can use this Lime to explain. The different MLDL models. And once you apply this explainable AI, so it gives you more picture to take decisions. You can be more precise in taking decisions. For example, now you are able to understand why. You can easily get why and why not, and how. For example, I know why you are success or fail. I understand, so I trust your insights, because you will get to know and also why these features are behaving like that. You can explain the features, but in black box you are unable to explain the feature. That is why there is a difference of this black box and explainable AI. Explainable AI explain the black box. This is a simple term. Okay, now there's something called interpretable AI, which is for example, decision tree, linear regression. This you can easily interpret. But explainable AI, where there is a complex model where you require a lot of processors and all, it requires more time to explain. That is a this advanced model. Okay, for example, artificial neural network is one of the example where they use black box, and that require explainable AI concept to explain. Okay. Okay, so there is some this framework called Lime. Okay, so local interpretable model agnostic explanation. So this is used, this Lime is used in Python, this framework. So the beauty of Lime is that accessibility and simplicity. The core idea behind Lime is it's exhaustive, and also if you throw any models to this Lime, they will give you some explanations to it. So that is why it is called model agnostic. Okay, so they use this black box separately. Okay, because for example, if this is a classification problem, for example, I'll show you using the data set. There is one use case here. So how this model is going to work. Okay, so let me switch to this the data set. It will help us. Okay, and save the time also. Okay, so this is one case. Okay, in this case we are trying to predict the online shopper's purchasing intention. Okay, so in this case I have a data set. I'll show you, and there are different features, and we are trying to understand why some online shoppers are not purchasing and they are not converting into the revenue. And there are some the reason. We are trying to understand the reason, because we have different features available, and based on those features we'll try to understand and try to categorize it, whether our customer will purchase or not, or they will convert into revenue or not. Okay, so this is typical case in e-commerce industry. Based on their historical data, they try to capture this purchasing intentions. So it's very important in e-commerce industry. Okay, now, so this is a typical data set where there are, let's see, there are 14, 16 features, if I can see. There are, and the last one are this R. If you see this R, revenue is categorical variable, false, true, maybe. Okay, false and true. This is a binary classification. Okay, so revenue is a target variable. and rest of these all are your feature variable. Previously all are feature variable. Okay, so now you can apply also logistic regression, you can apply linear discriminant analysis, you can apply a random forest, you can apply a decision tree, support vector machine, naive bayes, knn. There are many classification algorithms you can apply. So feature variables are, for example, feature variables are administrative durations, informational durations. These all are the some feature variable. Okay, and the target variable is revenue. So I think this is clear. Okay, so now, so feature variables, I've explained it. What I mean when I say administrative durations, informational duration. So these represents the number of different pages visited by the visitors in the sessions, and the total time spent in each of these page category. These value of these features derived from the URL informations. Okay, and these all are the the descriptions of the variables. Okay, you can easily read out this one. For example, bounce rate, exit rate, page view, page value. People working in this digital marketing, they can easily understand what is bounce rate, exit rate. Okay, there is something called a special day also in this data set. This could be your Valentine Day, Mother's Day. So in that day, people are logged in and they are purchasing something. So that is why this is one of the important variable here. And also what kind of operating systems they are using to purchase, to make purchase and all. So these all are the some features which are very important to categorize a person, whether he will turn into revenue or not, whether he will purchase or not. This is something related with this purchasing intention. Okay, so this is a typical you can say the feature selection. So I have selected these features, and this one is a target variable, this is revenue. So basically this is your target variable, response variable is basically a functions of all your input. Okay, so this is the mathematical modeling basically. Okay, so now I'm going to do this Python program because you have seen this data set. So let me open this Python programming. Okay, so in Python, I think in morning time, one of the speaker has shown you this Jupyter notebook. I think you might be aware of this. So there is something called data pre-processing. Okay, so these are some libraries in Python, basically NumPy, PyPlot, PLT. Basically this is matplotlib. I'm not using any plot here, but this plotting this is for data visualizations, basically matplotlib, and pandas PD, okay, for mathematical calculations and all. Now I'm importing my data set. Okay, so when I run it, I'll import this data set. My data set is in neural network folder in this C drive, and I have saved with this name online.csv, and I have stored it into dataset. This is object, basically I have made it. Okay, and now I will run it this head dataset.head. Dataset.head means it will give us the the 5 or 6 records, I think. Yeah, it will give you 5 first 5 records, dataset.head, so that we will understand that how are our dataset, what is there in the dataset. If you see, these all are the features, administrative to weekend. These all are the feature variable. But revenue, the last one, is our target variable. Okay, because this is a binary classification problem. Okay, now x and y, I have converted. I have taken this x and y means independent variable and dependent variable. You can say the feature variable is in y. Okay, so this is how we can apply this simple, I mean, programming data set. If there are some feature corresponding to feature, if it is a null or not, there is no, I mean, missing value. So it is giving us the corresponding to the features. Its data is there, so there is no missing value. I do not need to do anything. Now I'm trying to split the data into training and test set. In data science, or sorry, in machine learning and DL project, when you are trying to do any AI ML project, you're trying to convert 80% data in a training and 20% into testing. Okay, it's an I mean typical approach basically. So training and testing, I just run it, and then I run this classification problem. Just run it, and classification classifier those fit. So x train and y x training and y training, because I have converted in 80% into training. And we are applying this random forest. Basically, it's also a classification problem. Okay, classification ML technique, random forest. And these are some commands. I think pickle is to save classification problem. That is why we are importing this pickle. This is library basically, and we are running this pip install command line. This line is basically used to interpret your AI model. That is why I'm using this line command. Okay, so once I use this line command, so it will give us some, this kind of, verbose, or you can say it will give us this kind of, comments. And after that, you run this command, import line tabular. This is a command. Tabular means data is in your tabular format. Okay, that is why line tabular. The interpreter means you are trying to interpret it, and there is something called line tabular explainer. This is a one, the function that will explain our black box models. Okay, and x dot text dot ilog. This is one more command, and this one is very interesting. This last one, which I'm trying to show you. This one is the important one. Okay, so it will take some time. Okay, now this interpreter, this interpreter object is explaining the instances, okay, using this classifier, that is random classifier. These were the features basically. Okay, now what is making 0 and 1? 0 means there is a no purchasing intention, and 1 means purchasing intention. Okay, so now 0 and 1, what making people to purchase? So if you see this orange one, these page value, special day, informational, product related, duration, exit rate, all these things, these all features are making people to purchase. So if you are an e-commerce firm, then you can focus on these all features. Now this black box is able to interpret it. Okay, how our input and output is behaving and what is making to 1 and 0, the clear class distinctions. Okay, that is why XAI comes into play. Now I am able to understand how features are going to behave and what all features are important for me. Okay, this is very important for me. 1 minute. Yeah, sorry. So the last part. Where it was. So this is how you can explain, because now my model is able to explain what making 1 and 0, what is making 0 and 1, purchasing intention. So we can focus as a e-commerce company, we can focus on these features. Okay, so now 1 minute. Okay, so okay, so this is how we can explain XAI. 1 minute. Just give me 2 minutes, then we can close the session. Just 2 minutes. Okay, so we can focus on this, orange and 0. This orange and blue one. The blue one is showing the negative and positive associations, and these all are the factors, you can say, are making people to purchase. That is why as an e-commerce company you have to focus on these all features. So what kind of a business strategy you can adapt? You can do cross-selling, upselling. Also you can do some kind of sales and demand forecasting. You can do some kind of customer retention program you can run out, and also you can do targeted marketing, pricing optimization, logistic management. There are many more strategies you can apply to increase your sales and all. Okay, so Okay, this is, if anyone has any question, they can ask.
Sir, I have one question.
Yes,
Hello.
1 minute. Let me close.
Sir, tell me one thing.
Yes, yes, you can
Uh,
ask.
Suppose the
Yeah.
student don't have a engineering background and they want to do the research. Uh, for your
Mhm.
programming AI or machine learning, they should know then it is possible that they can use this technique, right, sir?
They must have at least a basic mathematical knowledge, at least. For example, even in IIT Delhi, they have come up with this MTech in this something called minds, machine learning, machine
No, no.
intelligence and data science.
Suppose
So I just explain.
no,
Let
no,
me explain
machine.
you what I'm trying to say. So the basic, you
Mhm.
must have basic knowledge of maths at least to understand this, at least basic maths to learn
No,
AI
no,
ML.
sir.
Yeah.
I want to know this programming. How the if the person don't have a computer background, how they will do this programming? This is my question.
I mean, they have some software like Orange, parallel to the Python. If
Hmm.
you don't know Python, based on this Python
Okay.
back in day, there is some software called Orange SPSS. At least you can run this these tools, at least tool based. If you don't know how to program.
Okay. This is
Yeah,
this is
Kriti,
the
if you have any
free
question,
of
I
cost. It
think
is
Kriti.
available, sir. Sir, it is
Orange
available
is
free
free
of
of
cost.
cost. Orange, yeah, Orange
Can
is
you
free of
provide,
cost.
sir?
Orange.
Sir, it's my humble request. In the beginning, also I was asked to Dr. Seema, ma'am. Can you provide this your
Hmm.
full video and his program the solving whatever problem you are solving and the steps whatever you are following on this program and the
Mhm.
software also the
Yeah, I
any
think
software
Seema
link
ma'am
where
is here.
we can
Seema ma'am can forward you. Yeah, the
sir we
Yes,
need
Seema
the
sir.
will
software
We'll
forward you.
also.
forward the recording, sir, to you.
Yeah.
Ma'am, we need the software also because I have already requested to you what software needed. If they will provide the link, then we can download.
1 minute. Let me. I think.
My sir,
Just
why
type
I am
orange.
asking?
I
Why I am
just type.
asking? Because my objective is to publish more or more CI paper. And as in a management science, I want to know which tool is better to do the good research, like machine learning or AI. Hello, hello, hello.
I think he got disconnected. He's joining. Sir is joining.
Yeah, sorry. I got disconnected. Sorry, sorry. Yeah,
Okay.
Sandeep.
Sir,
Yeah.
my question is,
Hmm.
for publication in a, CI general, which tool will be better for the management science student, AI or machine learning?
AI and machine, because AI is a bigger umbrella. Inside that, MLDL comes.
Okay.
So when you say AI, you are saying MLDL at the same time.
Okay. So, can you provide the any sort of link of the software where we can download and we will follow your instruction by your example so that we can further will
Hmm.
use this knowledge for our personality growth.
Yeah, basically, you can type Orange software in Google.
Yeah.
You will get this link. Orange, only Orange software. Just type it.
Sir, in
I think
your
it's a
PPT,
very,
can you share your this link also, please?
yes, yes, of course. It's there in the system. I'll share you. Okay.
Okay, ma'am, please
Yes, sir.
connect.
Definitely. We'll share
Yeah,
all the recordings and
because
PPTs.
in the beginning I was requested to you because it is needed
Yes,
for
sir.
the
We'll do
research
that.
purpose, ma'am.
Yes, sure.
Okay, thank you,
I
ma'am.
think Kriti has a question. She has raised her
Yes, sir.
hand.
Yes, sir. Sir, it was very nice session. Sir, I have a question. Like, sir, if we are, I'm a computer science student and I'm
Mhm.
working in some medical field related problem. But then,
Mhm.
sir, in that, it is very difficult to get an annotated data. Means it's really difficult for me. So then, in that case, how should I proceed?
Actually, I'll have to look first the data set. If because medical data is different. So I
No, sir,
mean,
it's like something of social media and a medical thing. So it's means getting it annotated is like a bottleneck for me right now. So how can I proceed? Because sir, we can go for a clustering site, but then it won't give an exact interpretation. So in that case, sir, what should I
So,
do?
Kriti, if you are seeing this, is it something related with, I mean, your data contains some textual format or what? I mean,
Yes, a textual
it's a
format,
text
and
data
I
or.
have few features on social media. I have few features on social
Mhm.
media as well.
Mhm. So okay, Kriti, I got it. If you are dealing with this text data, then you can apply text mining. Also, there are some techniques called non-negative matrix factorization, which I can remember it. That is also dimension reduction technique. There is something called topic modeling. I mean, you can apply so many things also in R, Python, and also in Orange as well. Kriti, you just download Orange as well. You can do so many
Okay, sir.
things
Okay,
in Orange as well, textual data as well. Okay.
okay, sir. Okay, sir. Thank you, sir.
Hmm.
Thanks. So can I
Okay.
connect to
Yeah.
you afterwards regarding my problem? Is it feasible for you?
I think you can connect with Professor Santanu Patnaik. It will be much better for me, and then you can connect with me. I think Santanu sir is here.
Okay, okay,
So, and yeah, you can connect with me. It's not an issue, but talk to Santanu sir first. Okay. Is it okay for
okay,
you,
sir. Okay, sir.
Kriti?
Thanks a lot.
Okay.
Yeah, yeah, yes, sir,
Okay. Thank you.
definitely, sir. Thanks a lot.
So thank you, everyone. It's time to close. Okay. Thank you so much. So, Seema, ma'am, if you like to say anything, yeah,
Uh,
Prashant, yeah.
yes, sir.
Yeah, Prashant.
On behalf of the VIT Noida family, I thank you so much for sir for being such an interesting discussion on ML algorithm and explainable AI using Python and listening to all the queries very patiently. Thank you, sir.
Yeah, thank you,
Also, now
everyone. Thank
coming
you.
to the valedictory session on our EDP. On behalf of the BIT Noida family, I would like to thank all the guest speakers for sharing such valuable and much needed information, including so many interesting facts and knowledge about data science and modeling with us and answering all the queries patiently. Also, the session was not possible by the external support from Sensotech CEO, Mr. Santanu Patnaik sir. I would also like to thank our director, Professor Dr. S.L. Gupta sir, and our EDP coordinators, Mrs. Seema Sharma and Ms. Muntaha Ahmed, for arranging this wonderful EDP for all of us. Also, thanks to all the faculties, scholars, students, and industry professionals for participating in the session and being engaging throughout the event. Thank you so much, everyone, for making our program successful. Now I request all of you to please turn on your camera for a while to take the group screenshot. Okay, thank you so much, everyone. Over to you, Seema ma'am.
Thank you, Prashant. Thank you, Satyajit sir, for such an insightful session. And thanks to all the participants for attending this two-day executive development program. We'll be sharing all the recordings and PPT of all the sessions shortly. And we'll also share the feedback form. Kindly fill it. And once we receive it, we'll be sending you the certificate. Thank you, everyone.
Thank you, ma'am.
Thank you, ma'am.